Welcome back to the deep dive. We're here to take that dense documentation and, well, give you the fast track to really getting it.
Exactly.
So if you've ever been stuck managing some kind of tangled multi-step process, maybe software dev, maybe insurance claims, logistics, whatever, the basic lists or simple flowcharts, they just don't cut it.
Not for the real messy stuff, no.
You need a proper map, right? Something that shows every decision point, every time data comes in from outside, and crucially, all the things happening at the same time across different teams or systems.
And that map, that powerful tool, that's exactly what we're diving into today. UML activity diagrams.
That's it. These diagrams are, well, pretty indispensable, especially when you need serious coordination. They're built to handle complexity, multiple players, tasks running in parallel.
Uh-huh. And our sources today are basically a mix of guides, examples, really showing the structure, the specific symbols, and how they're used across different fields.
So our mission today, it's really to unpack why these are so much more than just fancy flowcharts. We want to zoom in on the advanced stuff.
Right, things like the fork and join nodes, the swim lanes, the features that let you truly visualize simultaneous actions and spell out exactly who does what.
Giving you, the listener, that ability to actually see the system clearly, spot the bottlenecks before they, derail everything.
Let's get into it.
Okay, let's do that. We hear UML, Unified Modeling Language, tossed around a lot. But let's start basic.
Mhm.
What is an activity diagram? And why call it a behavior diagram?
Okay, so at its heart, yeah, it's a flow chart, but a very specific formalized kind. It's part of that UML standard, which means the symbols mean the same thing everywhere.
Universal language, okay.
Right, and it's a behavior diagram because it models the dynamic side of a system, how it acts, how it moves, how things change over time when stuff happens.
So not just the static structure, like a class diagram might show.
Exactly. This is about the flow of actions, the sequence, how things happen step by step.
Okay, so it lays out the workflow step by step.
Precisely. It shows the sequence, how actions connect up, start to finish, and that flow can be just one step after another, or it can branch off based on decisions, or, and this is really important, things can happen concurrently.
At the same time. Okay. So when should someone, a project manager, a systems analyst, reach for this specific tool instead of, say, just a standard business flowchart?
Good question. Activity diagrams really come into their own when the complexity ramps up, especially when you've got different roles involved or tasks that have to happen simultaneously.
So not for the super simple stuff.
Probably overkill for that, yeah? But use them when you need to really nail down a business process or untangle some complicated logic with lots of if this, then that decision points. Or even for modeling specific software bits like functions or operations when you're designing a system. They're the gold standard for showing dynamic behavior, how a process changes.
You mentioned that complexity point, the difference from a simple flowchart. They look kind of similar at first glance. What's the one thing that makes you say, nope, got to use an activity diagram here?
It's that ability to explicitly model things happening at the exact same moment. Concurrency.
Right.
Simple flowcharts. They usually just show one step after another. Activity diagrams, being part of UML, are actually engineered to support concurrent processing.
Okay.
So if your process has, say, Team A doing paperwork while Team B configures hardware, and both are part of the same overall delivery, you pretty much need an activity diagram to map how those parallel tracks work and potentially depend on each other.
That makes total sense. It's not just steps, it's coordinating those steps, especially when they overlap. Okay, let's dig into the building blocks, the symbols, learn the language, read the map.
Absolutely. So the core element is the task itself, right? The action or activity, like process application or validate user input. That's your activity symbol, the rectangle with the rounded corners.
Got it. Rounded rectangle, action. And every map needs a start and an end. Yeah.
Definitely. The start node or initial state is just a solid black circle. Simple. That's the single entry point.
Only one way in.
Only one. And the end. That's the final node or end state. It looks like a bullseye, a filled circle inside a slightly thicker open circle.
And you can have more than one ending.
Oh yeah. Complex processes often have multiple ways they can wrap up successfully, or maybe different error conditions, so multiple final nodes are common.
Okay. And the arrows just show the path, the direction of travel.
Exactly. Those arrows are the control flow. They just point the way from one activity to the next. But, like you said, processes aren't usually straight lines. When you hit a choice,
That's the diamond shape.
that's the diamond, the decision node. It signals a point where the path splits based on some condition. A question needs an answer.
Yes or no, usually. Or maybe more options.
Usually it's designed for a single input flow and then 2 or more output flows based on the condition. But how do you make sure everyone understands exactly what that condition is? No ambiguity.
Right. You need the rule written down somewhere.
Precisely. And that's the job of the guard. This is actually a really powerful little piece of notation. It's the statement, usually in square brackets, written right next to the output path from the decision diamond.
Okay.
It specifies the exact condition that must be true for the flow to go down that path, like order total $1,000 or user role equals admin.
So it pins down the business rule right there on the diagram. No wiggle room.
Exactly. It forces clarity and drastically cuts down on misinterpreting the rules. Takes vague policy and makes it a concrete, diagrammed instruction.
I like that. The guard makes it explicit. Okay, now let's get to the really powerful stuff. The features that, like you said, make these way more than flowcharts, handling things happening at once and showing who does what.
Right, this is where we leave basic flowcharts behind. Let's talk about modeling parallel activities first. You need 2 key symbols, the fork node and the join node.
Okay, fork first. What's that look like and what does it do?
The fork node is basically a thick bar, horizontal or vertical. It takes one incoming flow and splits it instantly into 2 or more outgoing flows.
Splits the path.
Yeah, and the key is those outgoing paths are meant to happen concurrently, at the same time. Think about setting up a new online account. The system might simultaneously send a welcome email and start provisioning security access for that user.
Okay, so 2 separate threads kick off right there, independently, running in parallel.
Correct. But what if the whole new user setup process isn't actually done until both the email is confirmed sent and the security access is fully provisioned?
Ah, you need to bring those threads back together.
Exactly. That's where the join node comes in. It's the mirror image, another thick bar. It takes multiple incoming concurrent flows and merges them back into a single outgoing flow.
And the critical thing about the join is it waits, right? It forces synchronization.
Forces synchronization. That's the crucial point. The process absolutely cannot move past that join node until all the parallel activities leading into it are complete. This is massive because it visually flags dependencies. If, say, provisioning access takes 2 minutes, but sending the email takes 2 seconds, the diagrams show you the whole process is held up, waiting for that 2-minute task to finish.
So it highlights your critical path, your bottlenecks right there.
Instantly. Makes it much easier to see where delays might happen and where optimization could have the biggest impact. That visibility is, well, a huge advantage professionally.
Definitely. Okay, so that's handling concurrency. What about responsibility? Showing who is actually performing each step.
That's the job of swim lanes, also sometimes called partitions. Think of them as visual lanes on the diagram, usually drawn as vertical columns, but sometimes rows.
And each lane represents, what, a person?
A department.
Could be any of those. It represents the actor responsible for the activities within that lane. It could be a specific role like manager, department like billing, or even a system like CRM system or external partner. So the lanes themselves don't change the order of the steps necessarily.
No, the control flow arrows still dictate the sequence.
But they add this layer of who's accountable.
Yeah, exactly. They massively clarify handoffs in complex processes. Imagine a diagram for processing an insurance claim. You might have lanes for claimant, agent, underwriting system, adjuster.
Right.
Every time that control flow arrow crosses from one lane to another, you immediately see a handoff, a change in responsibility, a potential point of delay or miscommunication. A diagram with 20 steps, but only 2 handoffs, is a very different beast organizationally than one with 20 steps and 15 handoffs.
Yeah, that visualizes bottlenecks caused by organizational structure, not just the technical steps themselves. Very powerful. Before we get examples, you also quickly mentioned object nodes and signals. Can you just briefly explain how they fit in?
Sure. They help connect the process flow to the actual stuff being worked on and to outside events. An object node is just a rectangle, and it represents the data or material that an activity uses or produces.
Like a document or a record?
Exactly. The output of create invoice might be an object node labeled invoice draft. And that object might then be the input for the approve invoice activity. It shows how data flows with the process.
Got it. And a signal?
A signal represents some kind of external event or trigger that the process needs to react to, or perhaps sends out. Often asynchronous things. Think about getting a one-time password via SMS for login.
Ah, okay.
The activity wait for OTP might be waiting for an incoming signal OTP received from an external system before it can proceed to verify OTP. It helps model how the process interacts with the outside world.
Okay, that adds another layer of realism. Let's make this concrete. Walk us through an example. How about that ATM management process for a cash withdrawal? How would the activity diagram map that out?
Okay, good one. So we start naturally with the start node.
Black circle.
Black circle, first activity, start session, maybe inserting the card. Then you get enter PIN, then enter withdrawal amount.
Straightforward so far.
Right. But now, first check. Can the machine even dispense that much? Or is it within daily limits? So we hit a decision node, the diamond.
With guards.
Exactly. One path out might have the guard amount invalid. That path probably leads straight to a final node like cancel transaction.
Makes sense.
The other path has the guard amount valid. Okay, amount is okay. Now, the ATM needs to talk to the bank. Right.
Right, authorization. That sounds like it could involve parallel stuff.
It often does, or at least dependencies.
Mm-hmm.
So after the amount is deemed valid, we could hit a fork node, the thick bar,
Splitting the flow.
splitting the flow. Path A goes off to do the critical task, send bank authorization request. Path B might do something internal, maybe less time critical, like prepare transaction log entry. Both start at the same time.
Okay, so path A is waiting for the bank network. Path B is doing internal housekeeping. What next?
Path A eventually gets a response. So on Path A, after the send request activity, there's likely another decision node, authorization granted.
Yes or no from the bank.
Right. If it's no, that path might branch off immediately to a final node like display denial message or return card.
Okay.
But if it's yes, authorization granted, then that path continues. Now, remember Path B, the logging. Both the authorization granted path from A and the logging complete path from B now flow into a join node.
The other thick bar, the synchronizer.
The synchronizer. The ATM will not proceed past this point until it has both the yes from the bank and confirmation that the internal logging step is done.
Ensuring everything is recorded before cash comes out.
Precisely. Only after that join node synchronizes both paths does the single flow continue to the final actions, dispense cash, then maybe print receipt, and finally ending in a transaction complete final node.
Wow, okay. That walkthrough really shows how it maps not just what the user sees, but the crucial background coordination machine, network, bank system, internal logs, and exactly where things have to wait for each other. You can see the potential failure points instantly.
And that really drives home the core benefits of getting fluent with these diagrams. Using these specific notations of the guards, the forks, the joins, the swim lanes gives you huge advantages.
So what's the number one takeaway for our listener? If they learn this, what do they gain?
I'd say it's reduced ambiguity and enhanced visibility. Because everything, the flow, the roles, the conditions, is pinned down so precisely, the diagram acts like an X-ray. It lets you spot structural problems early.
Like loops, dead ends, places where things might get stuck waiting forever.
Exactly. Bottlenecks, synchronization issues, you see them before you build the expensive system or implement the flawed process. You're moving from fuzzy ideas to a concrete visual model.
And we talked about swim lanes. That brings a huge organizational benefit too, right? Enhanced collaboration.
Absolutely. The diagram becomes a common language. The tech team can literally point to a guard condition and ask the business analyst, is this exactly the rule you meant? The compliance team can see precisely where checks are happening.
Fewer meetings going in circles, maybe?
Hopefully. It leads to smoother operations, fewer nasty surprises down the line, and much better, effective documentation. It's living documentation, a working model, not just some diagram gathering dust in an appendix.
Okay, so wrapping this up. The activity diagram isn't just another flowchart. It's the go-to tool when you absolutely need to manage complexity, especially where tasks run in parallel and knowing who does what is critical.
Right. It uses those fork join nodes for synchronized parallel stuff and swim lanes to make accountability crystal clear.
Yeah.
Honestly, understanding this gives you a serious edge in any technical or management role.
Being able to visualize and manage those critical path dependencies, those handoffs, it makes the invisible parts of a system visible.
Which directly translates to boosting accuracy, finding efficiencies, and improving productivity. You're tackling the hard problems in systems management head on.
That is powerful. Okay, before we finish, here's a final thought for you, our listener, to maybe think about later. We spent today focused on activity diagrams, which excel at showing the flow of control, the sequence of actions.
The what happens next.
Right. But they deliberately don't show the details of the messages being passed between parts of the system or the specific data structures involved. Other UML diagrams handle that. So the question is, when you're faced with a complex system, how do you decide what's more important to map out first? Is it the sequence of control, like we did today, or is it understanding the actual content and structure of the information being exchanged? Knowing the difference helps you pick the right map from the UML toolkit for the problem you're trying to solve.